are first, you have to know how to do chain rule. And we've done chain rule quite a bit recently, but let's review what this would look like when you have a function inside a function. So if y is equal to x squared to the 1 raised to the 100th power, what's dy dx? So we take the derivative of the outside, don't touch the inside, times the derivative. Then if we're working our way up here, we would say, okay, well, what if there's not an actual x anywhere? Like if y is equal to cosine of u, and I know that u depends on x, what is dy dx? What's the derivative of cosine of x? Negative sine of x. So what do you do with that negative sign? Just leave the u alone. I don't know what u is, but I just know that I need to multiply by the derivative of u. And the only trap here is you have to be careful about looking at which variable you're using for differentiation. So for instance, if y is equal to cosine of u, and we're asked to find dy dt. And I think you pointed out that we could use different letters here. So what would this one be? It would be negative sine of u times over dt. Absolutely. Yep. So that's the key insight here, is you have to be careful about how these things look compared to each other. Like here we have dx, so we're going to be looking at dx, and then when we change that to be dt, we're just changing that dt. So that's doing chain rule. Let's do one more, because this one might be a little bit trickier. So I'll give you a moment to look at it, and then I'd like for y'all to tell me what you have on it, or if you are stuck. So what if we have this expression? We have d by dx. We want to take the derivative with respect to x of x squared plus xy plus y squared. We can split it up and say this is d by dx of x squared plus d by dx of xy plus d by dx of y squared. And so that might make it a little bit simpler because I'm taking 3 separate derivatives. I am allowed to distribute derivatives over pluses like this. So what's the derivative of x squared with respect to is 2x? The derivative of xy with respect to x, I'm going to leave alone for a second. Let's leave it as something we have to do later. What's the derivative of y squared with respect to x? 2y, and is that all there is to it? 2y dx. 2y dy dx. Because anytime that there's this mismatch between the variable with which we're taking the derivative and the variable that's in here, we have to compensate for it by taking the inside derivative. Now for this final piece where we're taking the derivative of x times y, what rule would we need to use? We do have to use chain rule, but inside, this is product, right? So first we have to use product rule. So my a is equal to x, my b is equal to y, a prime is equal to 1, and my b prime is equal to what? Is it 1? No, it's dy dx. Awesome. Yeah. My y prime, my b prime here would be dy dx. Then I apply these pieces. I have my a prime b plus my ab prime. So I would actually get 1 times y plus x times dy dx. And any time that we have to take the derivative of y with respect to x, we're going to see a dy dx popping up. So here we had to use product rule, and then inside product rule, we had to remember, well, the derivative of y is dy dx. So if you're able to do this type of derivative, that's great. If not, start trying. It will come.